At the margin of a forest on a summer afternoon, a large white-tailed deer stands tail flicking, ears turning. And somewhere out of sight, drawn by the heat of that body and its dark silhouette, something moves.
You don't tell me where I can park, okay? I've been shopping here for 20 years, and you come out here acting like you own the place.
It comes in fast and lands on the flank. Then a pair of blades begin to work. They do not pierce, they cut. They'll saw a ragged wound into the skin, and into that wound flows a chemical cocktail refined over 100 million years. It keeps the blood thin and running while the animal it belongs to is only just realizing that it has been attacked. This is the work of a horsefly, and the insect responsible belongs to one of the most successful, most painful, and most quietly consequential families of blood-feeding insects on Earth, the Tabanidae. We tend to think of the spreaders of disease as small: the mosquito, the flea, and the tick. The horseflies and the deer flies have lived for the most part outside that conversation, dismissed as only incredibly annoying. Yet this is a family of roughly 4,400 species found wherever warm-blooded animals are, and carries some of the most devastating diseases of livestock in the world, along with a parasite that has tormented human beings for as long as we have existed. The Tabanidae, as a group, are enormous. Among all the blood-feeding flies, it is one of the most species-rich groups. They are large for flies, up to 3 centimeters long, which makes them the most substantial biting fly a person is likely to encounter. They are found almost everywhere. They are the horseflies and the gadflies, stouts and breezeflies, elephant flies, buffalo flies, moose flies and deer flies, clegs and greenheads. A family earns that many names only by being a persistent annoyance. There are a few genera that concern us most. Tabanidae are the true horseflies, the heavy-bodied biters of large mammals, and the source of many of the species most aggressive towards livestock and people. Chrysops is the genus of the deer flies, smaller, patterned wings, and uniquely important for human medicine. And Diachloris, which includes the yellow-bodied terror of the American Southeast. The males do not feed on blood at all. They take nectar and are harmless, and actually act as important pollinators. It is the female, and the female alone, who carries the blades and seeks out blood. But why does a horsefly bite hurt so much more than a mosquito? A female tabanid cannot mature a full clutch of eggs on the energy reserves she carries from her larval life alone. She needs protein, and she gets it from blood. She is biting because her eggs demand it, and she will press the attempt with a persistence that has made her famous. The manner of feeding is where the pain comes from. Mosquitoes are vessel feeders. Their mouths are thread thin and flexible through the skin until they locate a small blood vessel, and they draw from it directly, often without the host noticing until later. A tabanid, however, is a pool feeder. Her mandibles and maxillae are blades, and she uses them to cut and tear at the skin, slicing through the small surface vessels so that blood wells up into the wound she has made. Then she lowers a sponge-like structure, the labellum, and laps the pooling blood. The mouth parts of these females have been compared to a pair of scissors. She lacerates open the skin of her host. The blood is drawn out, and she consumes it. But the blade is only the half of it. To keep the blood flowing from the wound it has deliberately torn open, the female injects a suite of compounds to prevent clotting. The bite, then, is not a single event, but a chemical attack, and the itching, swelling, and lingering soreness that follow are the body's response to having been interfered with by these chemicals. Because the wound is large, and because the act of pool feeding takes time, the female is frequently interrupted. But she doesn't give up. She moves and then returns, often to the same animal or another nearby. The adaptations that make her such an effective blood feeder are exactly the adaptations that make her a dangerous carrier of disease. To understand where horseflies come from and why they are so difficult to control, we must look at the 3/4 of their lives that pass out of sight. Having taken her blood meal and matured her eggs, the female seeks out the edge of water and saturated ground to lay those eggs in a compact mass. They hatch and drop or crawl from the egg mass into the mud, and there they begin to develop. The larvae of tabanids are predators. They move through the wet surface, hunting other insect larvae, worms, and other soft-bodied prey. When growth is complete, the mature larva typically moves into drier ground at the margin of its wetlands and pupates there in the soil. From pupa, the adult emerges, and for the females, the cycle of host-seeking, biting, and egg-laying begins again. The hidden life of the immature stages has a practical consequence. Because the larvae are dispersed through mud and wet soil over a wide area, and because those breeding habitats are often extensive, protected wetlands, there is no straightforward way to attack tabanids at their source. You cannot drain a salt marsh or rainforest swamp to be rid of the flies it produces, at least without destroying everything else there. Horseflies and deerflies are creatures of disease for both animals and man. The most basic way they spread pathogens is through simple mechanical transmission. Their mouth blades and the labellum, still wet with the blood of their first victim, carry living pathogens directly into the fresh wound of the second. Everything about tabanid feeding makes this efficient. The large, bloody, lacerating bite, the habit of being driven off before the meal is finished, and the tendency to resume feeding promptly on the same or nearby animal. And the list of pathogens tabanids can move is very long. The family has been implicated in the transmission of more than 80 viral, bacterial, and protozoan pathogens. Among them are some of the most dangerous names in medicine: anthrax, tularemia, bovine anaplasmosis, and pasteurella. Most consequently of all, several species of trypanosoma can be spread. The toll of all this falls heaviest on livestock. Animals harassed by tabanids cannot feed normally, they bunch, they move, they expend energy in defense rather than in growth or milk. Of all the relationships between tabanidae and human disease, one stands apart. It is the one instance in which a parasite is cyclically transmitted among human beings by a horsefly. The parasite is the filarial nematode Loa Loa, and the fly is the deerfly of the genus Chrysops. Loiasis is known vividly and accurately as the African eye worm. It is endemic across Central and West Africa, where many millions of people live in areas of meaningful risk. Estimates have placed well over 10 million people in zones of high transmission. The two flies that carry it are Chrysops thalacea and Chrysops dymediata. They breed in the muddy margins of streams and swampy grounds of forests and farms, and they have evolved specifically to feed on humans. They are strongly attracted to the smoke of wood fires, which means that cooking actively draws the flies towards the people gathered around them. When an infected person is bitten, the deerfly takes up the tiny larval stages of the worm, the microfilary, circulating in the blood. Inside the fly, the microfilary undergo development, migrating and molting through the successful larval stages until they reach the infective third stage and gather in the fly's head and mouth parts, ready to be deposited into the skin of the next person the fly bites. There, the infective larvae enter the new host through the wound, mature over months into adult worms, and begin the cycle again. Once in the human body, the adult Loa Loa does not stay put. It migrates through the connective tissue beneath the skin, and on occasion, the migrating worm passes across the surface of the eye, visible and mobile. In drug-resistant hotspots, where the parasites have begun to defeat the medicines used against them, understanding the relative contributions of tabanid transmission becomes important to managing the disease at all.